Hi everyone, welcome to Tutorial 5. In the past two tutorials, we looked at processes in the ocean and the atmosphere that affect Earth's large-scale climate. In this tutorial, we'll focus on terrestrial processes that influence temperature and rainfall. So this map is showing the average annual surface temperature on Earth, and we spent some time talking about these patterns in a previous tutorial. But in addition to the annual average temperature, another important factor to consider when thinking about Earth's climate are changes in seasonal temperature. So this map is showing variations in monthly average temperature throughout the course of a year. And these seasonal variations in temperature can cause changes in the northern and southern hemisphere temperature gradients, and it can also cause changes in land-sea temperature gradients, which is the difference between the temperature of the land and the ocean. And both of these temperature gradients can have significant impacts on rainfall. For example, the northern and southern hemisphere temperature gradients that occur seasonally influence the Intertropical Convergence Zone, or the ITCZ. The ITCZ is a band of moist converging air in the tropics that produces large amounts of rainfall, and it migrates seasonally in a north-south direction towards the warmer hemisphere. In the map on the left, you can see this is showing changes in the monthly amount of rainfall, with dark blue colors indicating increased rainfall and green and white colors indicating lower amounts of rainfall. And you'll notice that in the tropics, there's this band of really dark blue indicating a high amount of rainfall. But the location of this band moves north and south throughout the year. And it moves to the northern hemisphere when it's warmer in the northern hemisphere during summer months, and it moves to the south when it's warmer in the southern hemisphere during the southern hemisphere summer. And this is also depicted in the figure on the right. You can see that the location of this ITCZ band of rainfall migrates north and south seasonally. And the positioning of this band of rainfall, in addition to varying on seasonal timescales, can also change on much longer timescales as the mean climate state varies. And if we think back to Tutorial 3, when we were talking about Hadley circulation, we discussed how the warm air in the tropics rises and condenses. And this is actually the process that contributes to the formation of the ITCZ, because this warm air mass, as it rises, it condenses and produces this band of high rainfall. In addition to seasonal changes in the temperature gradient between the northern and southern hemisphere, seasonal changes in the land-sea temperature gradient can also impact large-scale climate patterns. Specifically, changes in land and sea temperature drive a climate phenomenon known as the monsoon. Monsoons typically occur in the tropics and subtropics and are seasonal changes in the direction of the strongest wind. These changes in wind are often accompanied by corresponding changes in precipitation, which results in dry and wet seasons in regions such as India, Southeast Asia, and East Africa. During present-day Northern Hemisphere summer, land in these regions is warmer than the ocean, so the winds blow towards the land, resulting in heavy rainfall over the land. In contrast, during present-day Northern Hemisphere winter, the land is cooler than the ocean, so the winds blow away from the land, resulting in heavy rainfall over the ocean and dry conditions over the land. So these changes in rainfall and temperature associated with monsoons and the migration of the ITCZ are just two examples of climate processes that vary on seasonal timescales. And this highlights the importance of understanding seasonal and monthly climate data in addition to average annual measurements of climate. In this tutorial, we'll use data analysis tools in X-ray to explore seasonal variations in global temperature and precipitation data.